Hi, this is Dr. Bitla Venu. Today I would like to discuss CNC part programming in continuation to my previous session. Let me quickly go through what I discussed in my last session. In the previous session, I have discussed the miscellaneous functions which are responsible for the movements of the, or which are responsible for the control the machine tool. These codes are the functions are responsible for the controlling the machine. The codes are the functions are responsible to control the machine, like spindle movement, whether to spindle rotating clockwise or anti-clockwise, whether the coolant is on and off, whether to program start and stop. All these control will be related to the and comes under the miscellaneous functions. Then in the last session, we are also discussed the some of the preparatory functions, important preparatory functions like the linear interpolation, circular interpolation we have discussed. Then we are also discussed the positioning of the tool, absolute and incremental positioning also we are discussed in the last session. But in today's session, even in the last session, we are also discussed regarding the different types of programming formats like the fixed block format, tab sequential format, word address format were discussed. Fixed in the case of fixed block format, and the block is fixed, the number of words in that block is fixed. In the tab sequential format, each word is separated by a tab, and we need not repeat the words which are in the previous block. So if any of the word, if any of the parameter in the previous block is repeating in the next session, next block, we are not supposed to specify that word in the next block. This is what one of the flexibility of the tab sequential format. In the case of fixed block format, every word needs to be repeated, even it is not changing, even the value is not changing. Like suppose if you are performing the turning operation, the speed is same for the next cut also. In that case, we will not repeat the word, that word in the case of tab sequential format. Simply we will put the tab word and the previous value will be taken by the machine. But whereas in the case of fixed block format, we need to specify. When it comes to the advantages of the tab sequential format, it reads word by word, and all the words will be kept in the memory of the control unit, and those memory is again in turn converted as a signal as and when the reading of the block completes. Again, the machine is going to perform the work according to the signal. In the case of fixed block format, the reading will take place at an instant, that not word by word. Everything, every character and every block will be read at once. So that is the advantage of the fixed block format. But when it comes to the programming, tab sequential format is having some advantages, and at the same time we have some disadvantages. So in tab sequential format, the reading will take place word by word. Then when it comes to the word address format, this is very much flexible, and in any of the commercially available software, use this word address format only. The almost all the commercial softwares available, CNC part programming softwares, are based on the word address format. It is very much flexible. You can vary the block syntax, you can vary the block a sequence. In the case of tab sequential format, then fixed block format, it is having the sequence. We need to follow the sequence of words. Whereas in the case of word address format, it is not necessary to maintain the sequence, same sequence of the words. We can vary the sequence of the word. That is the advantage of the word address format, so that it is very much flexible. Each word is having some significance. Example, you take S word, T word. So everything is having some significance. So S word indicates S thousand. Example, you take S thousand. S indicates the speed. Thousand indicates the value, numerical value of the speed. So each word is having some significance, so that the system can read. The programming is very much flexible if we program using the word address format. So these three types were discussed in our last session, but in today's session, we will discuss the one of the important G code, that is tool compensation, cutter or tool compensation. We will see how what is the concept of tool compensation. Then we will move forward to discuss the CAD cycles. CAD cycle means repetitive cycles. Example, you take the turning. Turning consists number of passes, number of rough cut finish, finish cut turning. So in even in rough cut also number of times the tool needs to repeat. So in that case, why don't we write a code in the form of block and we can reuse that code whenever we want by changing one parameter. So that is what happens in the case of turning cycle. Except in the case of finish cut, we can vary, but if whenever we are taking, whenever we are machining turning operation, so this code can be repeated, whatever the code which is placed between some sequential order, some parameters, some sequential block numbers. So that will be executed number of times to complete the work. So that is one example. So simple turning operation, we will see thread cutting cycles, we will see, then peg drilling cycle we will see. Then let me move forward. What is tool compensation? If the cutter axis is moving along the prolonged path in CNC machine, the dimension of the workpiece obtained will be incorrect. Suppose we assume that we are programmed some program. Okay, so in that case, the program we are uh, specified the coordinate values of the tool. So in what direction the tool have to move. So using the G codes. But those values are not considered the radius of the tool or length of the tool. Suppose if we change the tool with different diameter, so then the tool path definitely varies. So definitely that impacts the work accuracy. So the tool length or radius must be considered while programming is very, very important. That means we need to instruct the machine. So this is what the radius of the tool that the machine should calculate, and according to that the coordinates will shift. This is what happens exactly in the case of tool compensation. Either it may be a radius or it may be the length of the tool. Example, now you take an example. Um, Normally the cutter diameter is not included in the program. As I said just now, the cutter diameter is not at all considered. But when we specify the compensation is allowed to that program, this is what the radius. That means the automatically the coordinate values that we are specified in the program will be protected, and according to that we will get the work dimensions. So that means if you specify the radius of the tool, example, you take an example here, you take, this is what exactly the object that we want to mission. We are programmed in this path. So thick line that you can see here, we are programmed to move tool, and this is the required dimension of the object. When we program exactly in this path, when we use a tool of so and so diameter, the dimensions of the object will be less. Yes, you can observe here. We are not considered the radius of the tool here, so that we will get the lesser dimension component. So to avoid that, we need to specify the compensation. That means the program automatically, the machine automatically reads that this needs to offset. I mean, the system and the tool needs to offset certain distance to protect the accuracy of the work. Now, once you compensate the tool using M code, G41 or G42, so that automatically the system will consider, the machine will consider the radius of the tool, and that tool will be offsetted so that we will get the accurate component while machining. Otherwise, it will move forward and it will not, we will not get the accurate component. The machine will not be accurate. So to compensate, either it may be a length or the radius of the tool, we need to instruct the machine tool to compensate length or radius of the tool. This is what the compensation. We need to compensate the tool radius or length to protect the accuracy of the work or to get the desired accuracy. So as we can observe in this case, so if you compensate the tool, so by instructing the machine using G code, G41 or G42, so the tool will offset certain distance so that the programmed coordinates will be as it is. Whatever the coordinates that were specified in the program will be protected and the machining will takes place according to that. So this is what the compensation of the tool. You can use G41 or G42. G41 is used whenever you want to um, cutting the tool left side to the block, and if you want to machine the uh, component, or if you want to machine the component from the right side, so G42 is used. Okay, and uh, this compensation will be active until to cancel. So whenever you don't want compensation, so in that case we have to cancel that compensation. That cancellation of the compensation can be done by using a code that is G code, that is G40. So G41 is used to move the tool whenever we are compensating the tool to the left side to the component. And suppose if we want to compensate the tool right side to the component or block, we have to use Z40. And to cancel the this is compensation. To cancel the compensation, we are going to use G40. So G41, G42, and G40 are used to compensate the tool. Then let me move further to discuss what is CAD cycle. So basically CAD cycle is used, just now I defined in the last slides. So CAD cycle is a pre-programmed sequence of events, pre-programmed, which have already there, some code. If you want to use that code repetitively, or the motions of the tool. Suppose if you want to move a tool repetitively, in that case, we write some code and we re-execute that code continuously. Repetitive operations, like suppose if you are doing turning operation with 3 mm depth of cut, that should be repeated until to reduce the diameter of the component to specified value. So automatically, if you write some code, if you write some cycle of code, so that code will be repeated until to get the final value. That is called the cycle. Example is the turning cycle, drilling cycle, reaming cycle. So that takes place. So this is the way of conveniently performing the repetitive machine operations. As I said, it can be drilling, it can be threading or boring, can be repeated any number of times using a cycle. Cycle means it comes to the original position. So where you are started, and it will take some depth of cut, or it will take some radius, and again it will be reoperated. So every CAD cycle has a fixed cycle format. I mean the CAD cycle for the drilling, CAD cycle for the threading, CAD cycle for the boring are entirely different. So there is no unique cycle to perform all the operations. Every cycle is having unique syntax and unique format. It's a great resource to make manual manufacturing easier. I mean, if we use this, definitely it will become easier to the programmer instead of repeating the code number of times. If we use cycle, so that operation will be completed. So often utilized and can be cycle save time and effort. So this cycle can save and time and effort of the programmer. Then let me move further to discuss the simple turning cycle. Simple turning cycle is going to use G code, that is G71. In turn, you can call this a G71 turning cycle. So this is used for rough material removal, rough cut turning. G71 turning cycle is basically a rough cut turning, which is used to remove the amount of material from the component some extent in rough way. Means after that we have some machining operation. It may be finishing or it may be other threading operation, but directly we cannot use the surface for other applications. But after that we have some machining operation. So rough cut finishing, rough cut turning, G71 is used. Okay, so this G71 turning cycle can control the parameters like the depth of cut. It can control, I mean, these are the inputs that we need to give for the G71 turning. So the first input is the depth of cut. It is obvious that if you want to turn any of the component, we need to provide the depth of cut. So similarly, in this case also, this cycle requires the depth of cut. Then we need to give the retract height. Retract height means after completing one cycle of operation, so one pass or one cut, a cycle consists number of passes. So after completing one pass, the tool needs to come back and it should be placed at a certain height to execute the next pass or the next cut. In that case, the tool needs to maintain certain clearance between the workpiece and the tip of the tool. So that distance or that height is called the retract height. The distance between the work plane and the tip of the tool after completing one pass or one cut before going to the or before cutting or before performing the next cut. So the tool needs to lift certain height. So before going to the next cut, so that height is called the retract height. Then this height we need to specify, and then finishing allowance in along x-axis, z-axis we need to specify. Finishing allowance we need to specify. That means this is going to leave some amount of material on the work plane along x-axis, along z-axis for the next pass. So some extent of material we are specifying for the next pass that should be left for the machine cut, finish cut. So that we can provide on the machine. How much amount of material needs to be left for the next pass for finishing. So that we can provide. Then cycle cutting speed and spindle speed. Yes, you are performing an operation, it requires feed and spindle speed. So these two are also very important parameters for the turning cycle. This is exactly the syntax of the or the format of the simple turning cycle that you can see here. G71 followed by U and R. Then it also this consists two blocks of form. This turning cycle consists the two blocks of code. One is G71UR and the other one is PQUWFS. So these are the parameters we will see in this table. This first block consists U and R. U indicates the depth of cut and R indicates the retract height. As I said just now, what is retract height? So where the U letter followed by one numerical, so that indicates the depth of cut for all the passes during the rough cut turning. Then this R followed by some numerical value. So that numerical value will be lifted. The tool will move to that height after completing one cut or one pass. That is called the retract height. Then the second block indicates the contour start block number. That means it is a sequence number and the starting sequence number, and Q indicates the ending sequence number. That means this is the code that needs to be repeated. So the code placed between P and Q sequence numbers will be repeated to complete the operation, to complete the cycle. Okay, so to complete the rough cut cycle. So and we need to specify U. P and Q is the sequence numbers of the blocks of the address of the blocks are the sequence numbers of the block. We need to specify here P and Q. Then U and W are the finishing allowance along z-axis and finishing allowance along x-axis. U indicates the finishing allowance along x-axis, then W indicates the finishing allowance in z-axis. So those values we need to specify. Suppose if you want to leave some amount of material for the next pass for the finishing, so we can specify the X and Y values also, X and Z values also. Then we need to specify feed and S for the entire cycle, for the entire G71 cycle. So let me move further to see. So as of now, what we have discussed is in the previous chapter. Let us discuss this with a sample of code. Now you can see we have one sample of code here, N660 sequence number, G71, U10 and R10. Okay, so we must require this simple turning cycle consists two blocks. One is first block which carries the depth of cut and the retract height. The next block of statement consists the sequence numbers or the address of the blocks those we need to repeat from and to sequence numbers like P80. 80 is the here sequence number or address of the block, and the 90 is the address of the block. So these two blocks are sequence numbers we need to specify here, which needs to be repeated. Then U indicates the finish cut elements along x-axis, finish cut elements along z-axis. So those values, if you want to leave some material for the finish, we can specify, otherwise it is not necessary to specify. And similarly, feed value also specified here. So these two statements indicates the G71 turning cycle. Okay, so then these are the codes which needs to be repeated and which belongs to the turning cycle. These are also to be executed during the cycle. These are repeatedly executed. Now you can see here G00 is the rapid motion and X is the distance, I mean the radius of the object. This is the final dimension of the object that we need to produce. I mean this cycle needs to be repeated until to get this dimension X60. So you can observe this. This will be repeated for a length of how much length this turning should takes place. So in a linear interpolation mode, in a linear mode, the tool will perform the turning operation for a length of 75 units. Okay, if it is 60 is in millimeters, even Z75 is also in millimeters. So to reduce the diameter of a component for 60 mm, then here for a length of 75 along the negative z axis. Now that means almost in all the turning operations, the turning takes place the left side from right to left, the tool moves backwards, so that the value is negative here, minus 75 here. So this phenomenon can be observed with the figure here. Now you can see G71 turning cycle here. So initially we have a block of diameter 100 mm, so on which we want to reduce the diameter for 60 mm for a length of 75 millimeters. So this is what the requirement. So now let us try to observe the movements of the tool. Initially the tool is at this location, and somewhere else you do not know. It will come to the starting point. Then it will take the depth of cut initially. This is the first movement. This is the first movement. It will take the depth of cut. The depth of cut is 10 here. So this is the first movement. Then in the second movement is the turning with a depth of 10 millimeters. Now you see here, the first, this vertical axis movement is 10 millimeters. Then again it will move to the 75 millimeters in a linear way, in a linear path. So in a linearly, the cutting action takes place up to the 75 mm length. So, okay, this two path is from here to here. So then again the tool will come back to a retractive height of 10 millimeters in a 45 degrees angle. So exactly to protect the machine surface. So the tool will come back to the 10 mm height along x-axis that you can observe here. So with the 45 degrees angle that will come back here. Again it will come to the original position to the start or the starting point. This is what one turning pass, one cutting of the one pass of the turning cycle. So now let us see, this cycle needs to perform two passes. One is if you give 10 depth of cut, it reduces to 80 millimeters. Again if you pass 10 millimeters depth of cut, it reduces to 60. First pass is completed, the dimension of the diameter of this component is reduced to 80 now. So now to this cycle will be repeated until to reach the value of 60 millimeters that you can observe here. So after coming here, after coming to the initial position, so the tool will move to the 60 mm retract height. Okay. So again, it will take the depth of cut. This is the retract height. 5 is the retract height, and the 6 is the depth of cut. Again, the tool will take the depth of cut. Again, it will move linearly for cutting operation. Again it will take back retract height. Again it will come back to the starting point like this. So ninth point it will come. Okay, again up to here it will come. So up to here the cycle completes. So 6, 7, 8 and 9. So this is exactly happens. So suppose if you want to use, along with that, there is one more format to use the finish cut turning. So if we use finish cut syntax or block of format along with these two blocks, so that can be used in this way. Of course, that is not shown in this figure. Suppose if you want to specify, or if you want to specify the turning, finish cut turning along with the rough cut turning. So we are going to specify, we are going to use G70 code here, and we are going to specify the speed and feed values. Okay, so the system is going to use during the rough cuts. So these values are used. So that means feed value is used and depth of cut is used. Suppose if you specify any value between these 80 and 90, so those values are used during the finish cut. So G70, we are going to use G70 here, and the parameters we are going to list out here. So these values followed, I mean these values are used along with the G70 code. Those values are used during the finish cut operation. So these values are bypassed, and the values which are specified in between 80 and 90 are used during the finish cut, or whatever the value specified along with the G70 code is used during the finish cut. This is what the simple turning cycle. Then let me move forward. We are already discussed this explanation. The movements were already discussed. Then uh, let us see the thread cutting cycle. Of course, even thread cutting cannot be performed in a single pass. It should be repeated number of times to get the values or the specifications, the exact specifications of the thread. We need to repeat the thread cutting also number of times. According to the depth of cut, we need to repeat the operation. So this thread cutting operation we will discuss along with the figure, so that you can see here. This is exactly the format of the thread cutting cycle, G76 thread. So the G code used to perform the thread cutting is G76. Now you can see G76, this is exactly the syntax of the format of the thread cutting cycle. So G76 X U, then Z, W, K, D, A, F, E, I, P, Q. Let us see what are all these in detail. So X indicates the axis absolute location. So maximum depth of cut, maximum thread depth diameter. So this is X is the maximum depth diameter, maximum thread depth diameter. This is optional. Okay, then Z you can see here. So axis absolute location, maximum thread length. Okay, the maximum thread length, whether you want to specify, you can, otherwise it is optional. The maximum diameter or the depth of the minimum or the minor diameter of the uh, thread, if you want, you can specify, otherwise it is an optional. These are the two values, maximum thread length and the maximum depth of the thread or the minor diameter of the thread. This is also optional. Then K indicates the thread height. So you can observe here what will be the thread height. So that we need to specify. This is compulsory. Then first pass depth of cut. D indicates the in how many passes. I mean, this is the D indicates the depth of cut during the first pass and during the next pass until to reach the desired value. What will be the depth of cut? That we need to specify. I mean, during the cycle of operation, what will be the depth of cut? That we need to specify here. That indicates the D. Then A indicates the tool nose angle. This varies between 0 to 120 degrees. If you want to specify, you need to specify, or we are bounded to specify the angle of the tool nose radius angle also. Then feed rate we need to specify. If you want, I mean, sometimes if it is feed or lead, if it is a multi-pass thread, we need to specify the lead. Otherwise, if it is a single start thread, we need to specify the feed rate. Okay. Then U indicates the axis incremental distance start to the maximum. thread depth diameter that you can see here, same value. Then W indicates the axis incremental distance start to the maximum. So either in the x-axis dimension increment and the z-axis incremental distance, how much distance the we need to give the increments along the x-axis, how much distance the tool needs to increment along the z-axis. So that also, if you want, we can provide. Even with respect to the axis also we can provide. So these two are also optional. Then thread taper amount. So what will be the taper amount? So that also we need to specify. Radius measure, this is an optional. Then single edge cutting, load constant, single edge cutting. I mean, single edge cutting, the load acting on the uh, component also varies, whether it is multi-point or the single point. So based on that, this also varies. We need to specify whether it is a single point or multi-point. So based on that, all the parameters like the speed, feed can also vary. So that we need to specify. Then thread start angle. So what will be the start angle of the thread? Sometimes the start angle of the first thread and the remaining threads can vary, because to insert a bolt, to insert a nut on the thread, example, we are inserting our requirement to insert a nut on the thread. So during starting, the angle of the thread is little bit different than the remaining threads. So that also we can specify what will be the angle of the start thread, that we can specify. So this is called the thread cutting cycle. We provide all the values. We are going to call this syntax in a sample of program. This repeats. So let me move further to discuss the Peck drilling cycle. So it is also a drilling cycle, a deep drilling cycle, not a simple drilling cycle, not a deep hole drilling. In other words, we can call it as a deep hole drilling. So the G code used is GIT3. During the Peck drilling cycle, if it is a normal drilling cycle for a specified length or for a small length, it is not necessary to pull back the bit back and to flush away the chips. But if it's a deep drilling cycle or Peck drilling cycle, so it needs to pass some extent. After moving tool to a certain distance, the chips inside needs to be flushed away and needs to be taken out to complete deep hole drilling. So this happens, this should be repeated to the number of times until to reach the desired depth of cut. So this is called the peg drilling operation. The drilling will not be performed in a single depth of cut. So this should be performed in number of passes. If it is, if a drilling length is more, if the deep of the length is more, I mean depth of hole is more, in that case that should be repeated in number of times. So to perform the operation, we need to flush away all the chips, otherwise which may spoil the accuracy, otherwise the tool may jam. So due to jamming of the tool bit may break. So all this can happen. So to avoid that, the chips needs to be flushed away, and we need to spray the, we need to send the coolant. So by sending the coolant, we can flush away the chips. So this is what the peg drilling. So let me move further. These, what are the requirements to implement this cycle? It also requires some inputs. So we need to provide the initial height, feed plane we need to specify, from which plane we need to operate the tool. That also we need to specify. Peck increment, that means how much increment we need to give. So in a single pass, what will be the depth of cut? In the second pass, what will be the depth of cut? That also we need to provide. Then Peck increment is different and depth of cut is different. So that we will see with the figure. Now you can see this is exactly the drilling cycle. G83 is the Peck drilling G code. This is the syntax of the, or the format of the Peck drilling cycle. G83 is the G code. Then X, Y, Z is the coordinates of the tool tip, and Z is the plane. So on which plane we are performing the drilling operation. Then R is the reference plane from which the tool is going to move. Then Q is the position of the R plane. So from where we want to keep the reference plane. Either the reference plane can be not exactly near to the work plane. It can be placed above the height, above at a certain level from the work plane. So what will be the distance or the position of the R plane? That also we need to provide. So that means the tool is going to operate from this point. So then the depth of cut for each cutting feed, that is also very, very important, depth of cut. Then cutting feed rate is also important, and number of repeats also very important. Now you can see Q is here. So this will be the depth of cut for each cutting feed. For each feed, this Q will be the depth of cut. So then R will be the reference plane that you can see here. Then K will be the number of repeats. So this is exactly the final depth of cut we want to provide. So in a first pass, the tool moves here and it will reaches to the reference plane first. If we use Peck drilling cycle, the tool reaches to the reference plane first. So whatever the value that we provide, exactly our value here. So the tool will reach to that point, and again that reaches to the drilling will be performed using the depth of cut. So this tool will move to the first pass until the depth of cut. So using the feed rate that we have provided. Again, it will come back to the original position. Again, it will move to the reference plane here. Again, it will move forward to complete the second depth. So until to reach the final destination, that means to the final depth of cut of the drill. So the cutting action will be performed so that the complete the cycle, so that it completes the cycle. This is exactly the Peck drilling cycle used to for the deep hole drillings. Then in the next session, we will discuss the leftover cycles like the grooving cycle, boring cycle we will discuss. Then simple turning cycle, uh, turning CNC programs we will see. Simple programs like the step turning, plain step turning, we will start programming in the next session. Grooving cycle, as of now, we are discussed. We will look into that. Then boring cycle. So only the syntax format we will see in the next session. Then let me go through what exactly discussed as of now. And Peck drilling cycle we have discussed, and Peck drilling cycle is carried out using a G code, that is GIT3. And this is exactly the syntax or the format of the Peck drilling cycle that we need to use in the program, main program. Then we are also discussed the parameters in this Peck drilling cycle. That means these are all the inputs that we need to provide to perform this Peck drilling cycle. Peck drilling cycle is basically nothing but the deep drilling cycle. So deep hole drilling cycle. Then where it needs to be performed more number of cuts. So in a single pass, we cannot complete a deep hole because we have chips. Those we need to be flushed away using a coolant or using another mechanism. So this we are discussed, and then we are also discussed the thread cutting cycle. In the thread cutting cycle, we are going to use the G76. G76 is the code used to perform thread cutting operation. So we are also discuss the format of the thread cutting cycle along with the figure and what are the parameters. So exactly we can call it as inputs to complete the cycle. What are the requirements to complete the cycle? So these are the parameters, and we are also discuss the in detail parameters. So where it lies. So that also we are discussed. Then we are discussed the simple turning cycle with a sample code, and in this case we are also discussed the movement of the tool, how the tool is moving to perform while using the simple turning cycle. So basically it consists the two blocks of code that you can see. G71 is for the rough turning cycle. If we want, we can also use the finish turning cycle also, finish cut block also along with this blocks. So to perform the finish operation. So this finish turning, if we provide the finish statement here or the finish block here, so which will be executed the final cut of the rough turning cycle. So this will be executed finally, whatever we write. So the G code for finish cut turning is G70 and specified with the address of this two also, or whatever the values we specify followed by G70 will be executed in the final cut or the finish cut. So that we are discussed. Then We have discussed the format also in detail. What are the parameters used in a simple turning cycle? G71 U is the depth of cut that we have discussed. How the depth of cut will, tool will take the depth of cut for each pass that we have discussed along with the example in the previous slide. Then the R also we are specified. R is the retract height. After completing one pass or one cut, the tool needs to lift certain height. The tool needs to move certain height. So to take, before taking the next cut, the tool needs to move certain height. So that is called the retract height, how much amount of distance the tool is moving. So that is called the retract height. Okay, so that we are specified, and along with this we need to specify, this is the first statement, first block of statement, and it is the second block of statement. It requires the P and Q. So these are the statements which are executed repeatedly. Those block of statements numbers or sequence numbers needs to be specified with these parameters P and Q. Then U is the U and W will be the parameters. These are optional parameters. If we want to specify for the some value which needs to be left over for a finish cut along X and along Z. So if we want, we can also specify those. Then to perform turning operation, we require basic cutting parameters like the feed and speed along with this. So those also we need to specify. So this is the simple turning cycle. This we are discussed in detail. These are exactly the input parameters required to perform depth of cut, retract height, finishing allowance along X and Z. This is optional. Then cutting speed and feed is required to complete the turning. Then we are also discussed the what exactly the CAD cycle. What is the meaning of the CAD cycle? We are defined. What is the advantage of the CAD cycle? If you use the CAD cycle, definitely it saves the time and effort of the programmer. It saves the time and effort of the programmer. That we are discussed. Then we are also discussed the compensation of the tool. What is the compensation of the tool? Along with an example, if you don't compensate the tool radius or the tool length, the accuracy of the workpiece or the dimensions of the workpiece is not according to the required dimensions. So to compensate the tool dimensions, either it may be the radius or the length, to protect the coordinates that we are provided in the program itself. So those are protected and we will get the exact work. Otherwise, the dimension that we get on the original component or the work component is different so than the provided on the program. So these are going to, we need to compensate, we need to instruct the machine. So these are the values, this is the dimension of the tool. So the tool will be adjusted and the coordinates specified in the program will be adjusted. So to protect or to get the exact dimensions of the work. So then we have discussed the compensation. The compensation will be carried by using G codes. G40, 41 and 42 will do 42 to cancel the 40 to cancel, I think 40 is to cancel, 40 is to cancel the compensation, and 41 is for compensating. When the tool is moving left side to the component, we need to use G41 to compensate the tool nose, tool radius. Whenever we are performing the operation on right side to the right side to the component, we are going to use G42 to compensate the tool radius. So then to cancel the compensation, so we have to use Z40. So this is what we have discussed as of now. In the next session, we will try to discuss the few more cycles, boring cycle and grooving cycle we will discuss. Then we will move further to discuss to see sample codes of for turning cycle. So not turning cycle, simple turning operations we will discuss in the next session. Simple turning program, how do we write a program to turn the diameter, to reduce the diameter from so and so diameter to so and so diameter, that we will see. So thank you one and all for this session.